Hi everyone, I'm Aneesh, the founder of DevVoid, and today we'll be continuing with our DSX AI series. Just a quick note I want to tell before we proceed over here is that I, from now on, will probably utilize AI a little bit more, and I'll be focusing more on the explanation side and rest on the syntax and coding side because, again, the whole point of DSA over here is algorithms and data structures and understanding them and less of brute force typing and stuff like that. That is mainly syntactical things. We can do a separate course talking about how the language comes into picture over there. But the concept I'm talking about is more about theoretical and more knowledge based. And applying it is a different matter itself. That's the reason I'm telling I'll use AI for it because that's not necessarily part of this. Yes, applying it is important, and otherwise there's no value in it. So you need to learn how to apply it. But the thing that'll help you in that is doing like a proper Python course or JavaScript course or Java or C, C++, whatever, whichever language of choice. But the things I'm teaching overall, right, they can be applied in all of those languages and any languages as well, programming languages, right? So that's something I want to focus on more from now onwards going forward. So we'll be utilizing, like I said, ChatGPT a little bit more for the coding aspect, and we will be thinking on the more on the thinking aspect. Okay. Very important. I do not want you guys who are doing this for the first time to do that though, because yes, that's good, but it's also important to understand the concepts and being able to apply it. I have applied it multiple times, so I have the leverage to use it. If you're doing it for the first time, if you're learning, do not do it. Okay? Very important. Because the skill set will be from being able to apply it to using ChatGPT to be able to apply it. That's what you'll be learning for yourself. That's also fine if that's what you want to go towards in your learning journey. Do you want to be the one being able to apply it, or do you want ChatGPT to be able to apply it? That time it's two different skills that you're training on. The first one where you use ChatGPT, it's going to be on how to tell someone to do your work kind of deal. The below one is how to do your work, right? So there are two different skill sets, and I will be doing the tell someone to do the work part because I know how to do that work. But if you guys are doing it for the first time, do it for yourself and then, okay, try this approach. But anyways, that being said, we are going to move a little bit faster now, and of course properly as well, because like I said, there are a lot of things going on right now. And yeah, so without further, I guess let's just begin. It's almost, I think, 2-3 minutes already done. But yeah, so the problem today we're focusing on is binary search. We are done with almost 6 problems, I believe, till now. And last one we did was valid parenthesis. So today we're going to look into binary search, and I have it open right here. So let's begin with this. Okay. By the way, binary search, okay, first we'll read the problem statement. Given an array of integers, which is sorted in ascending order, very important, and an integer target, write a function to search the target in nums if target exists. Then return its index, otherwise -1. Very important is the last line over here. You must write an algorithm with O of log n runtime complexity. Okay. So let's break down the problem first. Input, output, and understand everything. You can see the example here. I'm going to write down that in the whiteboard and proceed. So very important. We're going to overall learn two things over here. One is linear search and binary search. Just keep these names in your head so that when we do apply it, we will, how to say, link our implementation with that names. But yeah, so what you're going to do is look at the problem first. Given an array nums 1, 2, 3, 4, whatever. It doesn't have to be 1, 2, 3, 4. It can be 1, 5, 10, 20, whatever. But the point is, it's an array of numbers. And let's just look into constraints as well at this point. They never say it's only positive, so it can have negative as well. So I'll just add one negative -1 here, and just for the sake that we understand properly. But nums is the input, and then target is also the input, is equal to some number. Let's call it as 2 for this example that we are doing. And yeah, given this as the inputs to our system, we should apply some logic which we'll think about to give what is the output? Either the index, which is 0 to size n, let's say, or -1 if it is not present. Okay, so we have this as the problem overall. Let's take some examples and break them down first. So we'll take one example, -1, 0, 1 as the input nums, and target would be 0. If that's the case, what's the index where target 0 is present? It's in 0 for -1 and 1 for 0, right? So the result should be 1. Understood why? Because the value that we want to find in this array is 0, and that value is present in the first index because the array starts with 0 and then 1 and then 2. Okay, cool. Then what we're going to do is we're going to take one more example with the same nums, but our target this time will be 2. This time we'll see, okay, 2 is not present here, so well, we're going to return as -1 as the output. Okay, I give two simple examples where we return an index and where we return a -1 if it is not present. So this is the problem statement. This is what the problem says. This is what the first part of the problem says. Okay, that is this much. Now second part is interesting, but we will look into the second part a little later. Okay, for now we'll try to understand this problem and try to come up with the solution for this problem. Okay, so think of it normally, right? If I tell you that I have a red color stone, a blue color stone, and a yellow color stone, right? And let's say you have to access it one by one, and I want you to tell me whether there's a red color stone, right? Well, you'll see the red color stone in the beginning, and you'll be like, oh well, it's there. Okay, now let's say we want to find the blue color stone. What will you do then? Red color stone, that's it. For blue color stone, you'll check the red color stone first because I told you in order you have to see, and then you'll see the blue color stone, and then you'll be, oh, blue color is also there. Okay, let's do for yellow then. Will you red? Not there. Blue? Not. Yellow? And yellow. Oh, it's also there. Now let's take the final case. I'll draw on the side over here. Okay. And we'll take black color. Well, is it red? No. Is it blue? No. Is it yellow? No. So once we check everything, we know that it's not black. Okay. Okay. This ideology and this logic is called as linear search. What do? We take every value one by one by one by one. Okay. We'll take for this numbers only now again. -1, 0, 1. Okay. And -1, 0, 1. And then we'll take 0. What do we do now? We'll check -1. Is it 0? It's not. We'll go to the next item. Is it 0? Yes, it is. We're good to go. We'll take another example, -1, 0, 1, and try and find 2. Is it 2? No. It's -1. Is it 2? No, it's 0. Is it 2? No, it's 1. Boom, done. None of these values are, so we know for sure that answer should be -1 because it's not present. Now here the value is present, so the answer should be wherever we stopped. So 1. Got it? That is the ideology behind linear search. Okay, I thought I'll do ChatGPT, but I won't do anything for this. Maybe, you know what, I'll just do it. I know the code for it, but I just feel like typing. But anyways, so ideology, I hope you understood. If you didn't understand, again, how do we do it? How do you handle that? We go here, we say, hey, I'm trying to solve a problem where I have an array of integers and also a target value. I don't want the solution, but I want to understand whether my logic is correct. My logic is as follows. Okay. What is my logic right now? What is our logic? What is the logic we just thought of? The logic is check all values, and if any value matches the required value, then return the index. Otherwise, return -1. This is what our algorithm is. This is important for you guys to be able to do. This is what we are focusing on. That logic, thinking of the logic and putting that in the words, that is important. Okay. So, got it? So now it's saying us your logic is mostly correct. Okay. This describes a linear search, which is perfectly valid for unsorted arrays. Okay. Okay. So now it says it's good to go, right? Logic is perfect. But you see, okay, there are some things it mentions here. That is important for us. You see, in our problem statement, we have specifically mentioned it's a sorted array. That is powerful. I'll tell you why it's powerful. Okay. Tell me this now. If I have -1, 0, 1, okay, and I check whether 2 is equal to this middle one, okay. Let's take one more value, -2 and 2, okay. If I check the middle value, will I be able to tell in a place where it's sorted, very important, sorted, where it's -2, -1, 0, 1, 2. I know for sure that because 2 is greater than this value 0, that my if 2 is present in this, it should come to this side, right? Right? I can completely ignore checking -2 and -1 now, because I know for sure that my required result is to the right of this 0. Okay. Now we'll take the remaining part, 1 and 2. Okay. Now what we'll do is we will check again the middle of this, which in this case would be 2 itself, technically. Because I mean, I won't come to it how and why, but for now it's 2 technically. Okay. 2 and boom. Okay. Is it? Well, it is. So good to go. See, now instead of checking everything, I did only 2 checks. I checked for the center value here and center value here in the remaining one. Using those 2 checks, I got the answer 2 is present, right? Let's take one more example where it's not present. -2, -1, 0, 1, 2. I'll take a value 3. I'll again check middle only. Okay. Okay, if 3 is present, it should be to the right of 0. Do you all agree with that? Okay. Then what happens? -2, -1, 0. Oh, sorry. Then we ignore this much because we don't care about that anymore. And we will just check for 1, 2. Check 3 with the middle value. Well, if 3 is present, it should be to the right side of 2. Okay. Well, we'll go to the right side of 2. But interestingly enough, it's empty. There's nothing left. So, if you reach that empty place where there's nothing left to check, then you know for sure that your value does not exist. So you see, instead of checking 5 different items, I checked thrice, you can say technically, because I checked for empty as well. I checked thrice. Instead of checking 5 times, -2, -1, 0, 1, 2. Instead of 5, I checked only 3 times. Let's take a bigger value. Let's take a bigger one and think what happens. Let's take 10 size. I won't draw everything. Okay, maybe I will. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. We'll take the middle value, which is what? 10 by 2, which is 5. So it'll be this one. So let's try to find the value 10 here. Okay. 10 is not there, of course. So 10 will check with 5. Should be to the right side. Then it becomes 6, 7, 8, 9. Check the middle of this, which is 4 by 2. 4 by 2 is 2. 0, 1, 2. So 8 is the middle. And is this, well, 10 should be to the right of 8 as well. So we only have 9 left to check. And then what? 10. Check with 9. 10 should be the right of 9 as well, because 9 is less than 10. So what happens here? This also is not possible. Reach empty point. So -1. Now you see, instead of checking 10 times, you checked only 4 times. You see that power of that? Instead of 10, just 4. And as it grows like that, the number of the difference, or rather in this, becomes very significant with linear search versus binary search. Okay. But the challenge is it should be a sorted array. If it's not sorted, our logic does not work. That is, it should be to the right of something or left of something. Will never work because we are assuming that everything to the right is greater and everything to the left is smaller than the value that we're checking. So we go to the right if the value we want to find is greater than the current value, or we go to the left if the value we want to find is to the less than the current value. And that is the logic of binary search. Okay. We take the middle item at every point, see first whether that is the actual value. If it is not the actual value, then see whether it's less than or greater than. If the required value is greater than the current value, then go to the right. If the required value is less than the current value, then go to the left. That's all. And keep repeating until you reach either empty or the required value. That's all. That is the essence of the logic for binary search. So I'll write down here. Okay, what about this logic? Right. So in this logic, what is the plan? We'll say we check the middle item at every point and see if that's the required value. If it is not, then I see whether the required value lies to the right or left of this value. That is greater than or less than the current value. Right side is greater than the current value, left side is less than the current value. And if so, I will take that part and repeat till I either reach empty array or the required value. Exactly. This is the binary search algorithm. So it summarizes our logic. What did it say? Check the middle item. If it matches the target, return it. If not, compare the target with the middle item. If target is less than the middle item, search left half. If target is greater than middle item, search right half. Repeat this until you find the target or you reach the empty array. And that is exactly what is our logic. Okay. Got it? I'm going to take a quick read of what and all I'm showing here. But that's the logic. And now, because we already know the logic, and I told you I'm not going to write that code for you guys from now on because it'll take time typing and stuff. So I'm just going to generate the code. But here is where you ideally pause, understand the logic, write a code for it, and then verify it back with me in the video. Okay, this is how the process should work ideally, as if you're truly learning this and the core essence of it is learning, right? So pause the video here and then see the code and verify it's good too. Can you give me the code for this algorithm in pipe? Okay. And of course, very important disclaimer here. This is not what you should do in any competitions, okay? Or any interviews and whatnot. Like, you should be able to do this. That's the goal here. But since the focus of our whole learning process is using ChatGPT for learning, and also that I will take time to write this code, that's the only reason I am not doing this. But I know how to write this code. If you guys don't know how to write the code, don't do this, please, okay? But yeah, so I'm just going to take that. And very important, if you truly understand this logic, you should be able to write the logic as whatever you want, essentially, as in, or change it to this form. So I could technically give ChatGPT this context and it'll give the right answer directly, but I don't want to do that. Okay. Instead, I'm just going to convert this logic to work for our set of variables. Okay. So let's try target array. It's not array, it's what? Nums. Over here also, it's nums. Finally, run this code. And once I run it, good to go. Let's submit this. we are good to go. That is binary search. Similarly, your assignments or whatever you want to do exploration is to look into linear search and understand that as well. Because linear search comes before binary search, but in our LeetCode.io, it's focused on binary search, so I went for that. Like I said, we can cover every single algorithm, everything if you want in the future. But right now, our scope is limited to LeetCode 75 problems, and then we'll go forward. Okay. But yeah, that's all from me, guys. Hope you enjoyed it, and definitely like, share, subscribe for the video if you guys liked it and want to, be there for more. But yeah, it helps a lot. So that's how you can support the channel. And but yeah, thanks everyone, and take care. Hope to see you in the next episode.